So now we proceed with the example D. Okay, so example D is, the question is Laplace inverse of s over s square plus 4 of 2. Okay, this kind of question, if the question asks for property, use the property to find the inverse of this kind of function. Okay, so what we do is use derivative property. So what we do is we let first fs is, this is different approach with the question with log just now, with natural log just now. It's different approach, yeah? You see, okay? Fc 1 over s square plus 4. We just let fs as part of the function. Don't take the s, we just take 1 over s square plus 4. Like this. From this, we have to find ft for this fs. So our ft for this is, you have to inverse this. It becomes sine, so sine 2t, we have to divide by 2, right? Because we don't have 2 at the top. A equals to 2. Okay, if you can still remember how to do this. If you cannot, you have to make a review. Okay. Okay, so now we differentiate this. So we differentiate this, that means we Laplace inverse, we differentiate fs, this. How do you differentiate this? Whether you use, you can use quotient rule, or you just bring up s square plus 4. Okay, so it becomes like this. If you bring the denominator up, so you can use a composite function to differentiate. Okay, so it becomes negative. It's easier to use this. So when you differentiate, negative 1 bring down, s square plus 4, negative 2. Okay, and then you have to differentiate again the function inside. Sorry, 2s put here. This is the result of differentiation of this. When you use derivatives, what happened just now? The negative 1, 1, because we differentiate only once. T, 1. Okay, and then we have ft. Ft now is this one. Can't you see? This is different from example A. Okay, we take the ft from here, because this ft is the inverse of this. So we differentiate this, so ft is this. Okay, so now if we rearrange, we just simplify this. Okay, this, it becomes like this. Just bring these functions down, so it becomes t sine 2t, this one. Okay, can you see that this is equals to the question? Okay, so equals to the question. So that means whatever happened here, this function is the answer. Already in terms of t, right? All of them. So that means the difference is only negative 2. The question does not have negative 2. This is a constant, so never mind. The constant will just taken out. Negative 2, bring 2 here. So negative t, because it's a constant. So negative 2 here to be brought here. So we have negative 4. Negative 2. We got negative 2 into negative 4. So we have this answer. See? We get the answer already for D. This is different kind of approach. Okay? So that's all for only 2 examples for derivatives. Okay.